Hello. Yeah. Hey guys. Morning. Morning, guys. Thank you.
Here,
Thank you.
can I put some groups in that?
Morning.
Good morning.
How are you?
Morning.
Hey,
Good morning.
Kimberly. Morning, Ashley, Kylie. Hey, Michaela, James. Hey, James, were you here yesterday?
Mr. B, what's the weirdest game mechanic you've ever heard of?
I don't know. What about you?
Mine's just this one game based off of this anime called Solier, where you could either be a weapon or a monster, and then two people have to work together. One person has to be a weapon and one person has to be a meister to actually become a full character.
Yeah, that's unusual.
Yeah.
So we were walking with taking our walk before this, and we got back to the house, and there was a police car patrolling, and it was Officer Merle. He said, "Tell all y'all hi." He said he's going to head over there on Mason Street and make sure he was over there behaving. So
Okay.
Mason, you better watch out. He's not on here. Probably taking care of that bird. Okay, the pair deck is MBZGE. Misty Banana Zip Green Elephants. Okay, let me get it on my phone here. Okay, give me just a second. While you all are joining, I'm joining as well on the pair deck. Okay, we'll start in about 30 seconds. So we're going to be finish up like one or two more cones, and then we're going to start composite figures today. So on the slides, I'm going to scroll through a couple of them because we're not going to use them. So you just don't answer anything on the slides until I tell you, because a couple of them we're not going to answer because they're left over from yesterday. Okay, there's Mason. Right, anybody not logged in yet? Joinpd.com, MBZJGE. MBZGE. All right, so as I said, we're going to start talking about area of composite figures and just moving on here. All right, yesterday we talked about a cone and a cylinder. Would somebody be able to, let me add in a couple people here. Hold up just a second. Could someone unmute themselves and tell me what is the thing about a cone and a cylinder that's the same?
They both you have to the way to find the volume is you have to use pi.
Okay, so for both of them, you're going to use pi to get the area of the base, and then times the height to get the volume. What is the characteristic they both? Somebody else. What's the characteristic they both have that's the same?
They both have a circular base.
Both keep going. Yeah, they both have a circular base. They don't have to be sitting on it. Like on a cone, where the ice cream scoop would go would be the circular base part, even though it's not at the bottom, right? But that's called the base. What about the two of them is different?
One of them goes up to
Starts with a
what's the
V.
point called?
Vertex.
Yeah, the vertex.
Yep, the point.
The vertex, and the other one goes up to another circular base.
That's exactly the same. I need to make sure I've said that. The top circle has to be exactly the same size as the bottom circle, or it's truly not a cylinder. For example, if you look at a cup like this, okay, so if you probably can't see it. So if you have a cup like this, let me put it in front of my shirt. This circle at the bottom, we're pretending like it's the same as the one at the top, but is it truly the same? No. So an actual glass is mimicking the idea of a cylinder, but it's technically not one because the circle base at the bottom is not congruent to the top. So on a true cylinder, they have to be the same. Whereas on that soup can, they are truly the same, right? So they have to match. So you have to say on all cylinders, the base and the top are congruent. What's another shape that has that same idea? Not cone or cylinder.
Rectangle?
Rectangular prism. Yeah.
Yeah.
So prisms, same idea. The top and bottoms have to be congruent for it to be truly a prism. So if you have what looks like a prism, but the top and bottom are slightly different sizes, it's really not a prism. But it's the same idea, but it's truly not mathematically a prism. Okay, so quick reminder about the lesson. Thank you for doing a great job of making sure there's not feedback and background noise, and for staying focused on the lesson. I had that reminder on there yesterday, and I think that was a great reminder to help everybody remember that we just have a few minutes together and to stay super focused on what we're doing. All right, so these slides. Okay, so right here. So quickly, just a reminder of what we did yesterday. We talked about that to get the volume of this cone, I'm going to pretend like there's an imaginary cylinder that's there that I'm going to think about first. So let me draw a line to show you what I mean by that. So pretend like there's literally this, right? That goes there. And we're thinking about that cylinder. Now, I don't have the circle at the top. I pretend like that goes straight up like a cylinder. So we know that means that this portion and this portion are basically 2/3 of the volume of that cylinder that are not in the literal cone itself, right? So that's why we have this idea that it's 1/3 as much as the cylinder would be. So then you just pretend like you're doing an imaginary cylinder and you get its area, its volume, and then take 1/3 of it because it's only 1/3 as much. Who can remind me where that same idea has been the case with another kind of volume? Tell you what, just write that on your screen. Write that on the slide. Where's the other place we had that same idea where you did an imaginary bigger volume and only did 1/3 of it? And it also came to a point like that, a vertex. All right, so several people are saying a pyramid, and that is correct. I am going to correct something. I noticed several people on the Ed Puzzle video, the question had been asked about why were there a certain number of faces on the prism or the pyramid. And somebody said all of them, couple people said all of them have the same number. They don't always have the same number. For what I'm talking about is, so let's say I'm doing a prism. The number of faces is going to be determined by the shape the base is, right? I just wanted to clarify that from the feedback I was giving people on Ed Puzzle, that some people were thinking, they made the comment that all of them always had the same number of faces, but they don't have the same number of faces. So could someone elaborate what I mean by that? Somebody who hasn't talked? That the number of faces of a prism or a pyramid would depend on the base shape. What do I mean by that?
What you mean is, I'm trying to think about it on the fly, kind of.
That's fine.
It's kind of hard to describe. I think because of like the number, the width and the length of it determines the kind of the one of the lines of the.
So, okay.
Depending on
You kind of get what I mean?
Yeah. Somebody else want to also add in?
depending on how many sides the base has is going to kind of change the respective of the shape that's on top.
Okay. So let's say the base is an octagon, then that's going to be 8 walls that come up, right?
Mm-hmm.
If the base were a square, that's only 4 walls coming up, right?
Yes, because
So-
there's only the sides in the base.
That's exactly right. So that's what Graham and Fred were saying, that the size or the shape of the base is going to determine how many walls you're going to build up to match the roof, the quote roof. So is that also the case with a pyramid? The face number of faces is going to be determined on the shape of the base. And the answer is yes, because let's say it's this is the one I asked you about. Do all triangular prisms have 4 faces? And the answer is all triangular prisms do. I mean, triangular pyramids, because it would have the triangle base and 3 triangles coming up to the point, right? But if it were a square pyramid, it would have 5 faces. So it would be the number of triangles coming up to the point based on the base. Okay, so let me move this on to the next slide. All right. Get my phone back on. Okay. So here, we did not do this one yesterday, I don't think. I think this is where maybe we stopped. All right, so on the slide, if you will, I can't see which one. Is this a draw or a type?
Draw.
Draw, yeah, I see now it is. I had to move I wish Zoom had a way to move your stuff out of the way, but you have to, okay. So on here, I left a question mark in the formula. So again, we're going to take the base, we're going to get its area, and we're going to multiply it times the height, and then take 1/3 of all that because it's a cone, not a cylinder. So the question mark there is what goes in that question mark before you start? And if you already know, you can start drawing your answer in. What literally should go where the question mark is on here? What should be right there? Could someone who has not talked share? What would go there? So is it 8 times? Go ahead. Is it 8 times 8 is 64? Answer is no, it's not. Is it 4 times 2 is 8? Again, no, it's not. Fred, is it 4 times 4 is 16? Yeah.
Yes.
It's half the diameter, which would be 4, right? And then you multiply 4 times 4. So you're only getting this part here. So that little question mark should have in it 16. That's what should be multiplied. So go ahead, and if you'll write your answer in the blank on the slide. All right, and I'm going to share the screen. All right, so we know that we've got to take 16 times 3.14 times 9 and divide all that by 3 or multiply it by 1/3. All right. And when we do that, we get 37, right? 37 and 6,800 cubic feet. That person forgot to divide. All right, okay. So let's try one more and then we're moving on to composite figures. All right, so here you've got everything you need. This one's going to be easier because the numbers are easier, I think. So you're going to say 9 times pi times 10, and then you're going to take a third of all that. Do I have a volunteer who is not shared that would talk us through your answer? I see Melis, you have it. Kylie, you have it. Betty, almost finished. Nathaniel, you've got it. Pramita, James, Fred, somebody who wants to share how they got the answer.
I can.
Go ahead. Thank you.
Okay, so
I'll pull yours up.
okay. I did 9 times 3.14 and got 28.26.
Mm-hmm.
And then I did that times 10, and that's 282.6.
Mm-hmm.
And then I divided that by 3 and got 94.2.
So it's almost as if you take the pi part out and just go 9 times 10, and it's going to be about that answer. Raise your hand on your Zoom if you get what I just said. I'll say it again. When you're doing volume of a cone, if you basically do the 9 part times the 10 part, you're going to know about what the answer should be, because it's basically times 3 here, and I'm going to divide by 3. So that basically washes that, right? Not exactly, but close, right? So I'm just going to scroll down my Zoom and see who's got their hand up. Okay, Graham, Pramita, Kylie, okay. If you get it, okay, Jayla, Betty, Melis. All right. So yeah, that's just a way to check your work to know that you got it right. Okay. Now, moving on here, if you will just tell me for future reference, drag the dot where you feel you are with volume of cones. If we're good there, or if a majority of people need a little more practice at another time, not today. So if you'll just drag your drag your dot to where you feel you are. All right. All right, now let's talk about composite figures. Here's our first one. All right, so tell me some things we notice about the figure before we start. This one's not going to be hard. Give me something you notice about Josiah. Tell me something you notice about the shape of this figure.
It's a rectangle.
Okay, there's a rectangle there. Let me hear from Mason. What's something you notice about it?
There's two right triangles.
Okay, very good description. You didn't just say there's some triangles. There are two right triangles. Mason, what told you they were right triangles?
The square representing the 90-degree angle.
Perfect. Yep, exactly right. Courtney, what do you notice about the shape? That there's a rectangle and there are two right triangles. Are the two right triangles the same size?
No.
No, they are not. The one at the quote top is smaller than the one quote at the bottom. Melis, why do you know the one on the top part here is not the same as the one below? So in other words, this one is smaller than the one on the bottom. Why? What tells you that?
Well, because one has the measurement of 2 feet for one of the sides, and the other one has 3 feet.
Perfect. Yeah. The quote base of one of them's 2 versus the other one is 3. Now they both have the same quote height. Now you could argue that the 3 foot is the base and the 2 foot's the height. It doesn't matter, but they perpendicular are 2 by 3 and 3 by 3, so they're not the same. Let's see, Liam. If I were to take this triangle on top, so the one that I've got the arrow pointed to, could you tell me what is the area of just that little triangle?
The area is 3 feet squared because it is the base and the height divided in half.
Perfect. Yeah. So all he did was he said 2 times 3 is 6. Half of that's 3. Now, the reason I've given you this shape to start with and I'm doing these specific questions is because I want you to notice something that I'm going to stamp on here. Okay. So the cookie cutter method about here's 1, here's 2, and this, along with this little piece here, make a third square literally inside that triangle. That's how you know that you're confirming that formula works. And then I also wanted to point out this. If you look here, you can see the larger rectangle from which it comes. All right, Josie, will you tell me what you notice about the blue rectangle I just placed over that triangle?
I can't.
You can't see it. That's okay. You can't see it.
Oh, okay. So
Right
the
here.
triangle is, yeah, the triangle is half the rectangle if you
Right.
when it's drawn out.
And the point I'm saying is, we know that that's so simple, but that's the whole point of understanding. If you understand why the formulas work, you won't have a hard time remembering which formula goes where, because it's a lot of, if you learned these formulas the way I was taught them, where you just had to memorize them, they all would get jumbled up in your mind. You forget which one went where because nobody ever told me why. But that's why, because it's literally half of a bigger rectangle. And when you look at it on grid paper, you can literally see that there are actual 6 squares, and it's half of those because there's 1, 2 full ones and 2 partials that make another third one. All right, now, Angela, on the bottom triangle, so we know that one's worth, let me put that in. That right there is worth 3, okay? On the bottom, Angelo, we have a 3 by 3 rectangle, right? And it makes up another square that is hard to tell that it's different, but it is. Okay, there it is. All right, and inside there, can you actually see there are literal full squares colored in? Yeah, 1, 2, 3 full ones. And those 2 make a whole, and then there's a half. So Angela, what's the area of this triangle down here? Angelo, can you unmute? Are you able to? Okay, Kimani. Oh, there you are, Angelo. Go ahead, Angelo. Angelo, can you unmute again?
What was it?
So right here, I've got a triangle that's 3 by 3. But I literally have counted 1, 2, 3, 4 whole squares and a half. Because the formula is what again? Three times 3 is 9. Half of 9 is 4.5, right?
Yes.
Okay. Yes. Okay. Now we've got that done. And was it true that the 3-foot pieces right here needed to be there to be able to get this?
Yeah.
Answer is yeah. Okay. Izzy, tell me what this 8-foot part has to do with anything. What does this 8-foot part, what's important about that? Let's see, where are you? Are you not there? All right, Permita, will you tell me what this 8-foot part has to do with the importance of getting the total area of this shape?
Sure. So the 8-foot part is part of the length of the rectangle, and you need that to figure out the area.
All right, so I need to do 8 times 4 is 32.
No.
Wait,
you also have
wait. Why not? 8 times 4 is
Because
32.
that's not the whole rectangle.
Can I say something? Can I ask you a question, Permita? Is it the answer to some rectangle though?
Yeah.
Which is this rectangle, right?
Right.
But it's not the whole rectangle. Now, would there be any, Permita, I'm purposely doing this. Would there be anything wrong with me just doing that section separately?
No, but it's not as efficient.
Correct. It's correct, but there's a more efficient way to do it. Can you tell us the more efficient way to do it?
You do 8 plus 3, which is 11, times 4, which is 44.
All right. So now you see the shaded blue part. Okay. That actually is this. All right. Okay. Everybody good with that? So the area of the composite figure would be 44 for the rectangle, the whole rectangle. It would be 3 for the little triangle. And it would be 4.5 for the slightly bigger rectangle, which would give us a grand total of the area of the whole figure to be what? If you'll write that on your screen. If you've already drawn on your screen, that's great. But if you'll go ahead and write that also on your screen. All right. Did you all get 51.5 square feet? All right. Jayla, can you talk about this?
Yeah, so I did mine the way with the smaller rectangle, and then I got the area for the trapezoid, and then I added those together. I just felt like that was a quicker way to do it because you have to get the area of less shapes.
Okay. So I wanted to point this out that we did one way to do this. We did the big rectangle and the 2 little triangles. You could have done Jayla's method, which is she took this trapezoid and then this 32 square foot rectangle piece as well. That's another way. And then the third way would be the 2 separate triangles, the separate rectangle, and the separate smaller rectangle. So there's multiple ways to come at 51.5. I'm looking through to see if somebody else has done another thing besides that. Okay, Betty was doing the same thing there. That also works. Of course, my stuff's stuck on top of there too. But yeah, so again, composite figures are about looking at the smaller individual parts that make up the bigger shape. Okay, let's try another one. Okay, let me take this off, move it to the next slide. All right, you have another composite figure. What I would like you to do this time is you have to supply the measures as well. You'll also supply the measurements because you can get them from the graph. Hey, Melis, will you go ahead with that method you were doing, and then will you talk about it? I see what you were going to do.
Stop.
Double checking. Michaela, Kylie, your hand is up. Did you have a question? Or was that just from the before?
That's from before.
Okay.
Yeah.
I assume so. I just want to double check. All right, Melis, do you mind in a minute to start with yours? Because
Okay.
you're doing a different approach, which is a good approach, but it's different from everybody else's. But it is a correct approach. All right, so Melis, I'm going to put the screen on yours to start with. Do you mind to talk through what you're doing?
Okay, so I was gonna black out all the other part of the graph because it makes it easier to focus on the squares that are part of the shape.
Uh-huh.
And I was also putting dots there, just it's easier to count since there's a blue screen in front of the graph, so it blends the lines in more. And I've been putting lines on all the different shapes.
Okay. All right. So you could also think of it like this. I want to add something to hers. So if I were to say, let's actually look at this shape here. What if I just did this shape and subtracted out the parts that aren't in the blue part? Could I do that?
Yeah.
Yeah. So you don't have to do a composite figure by adding all the individual parts of the figure. You can also get the bigger figure around it and subtract out the parts that aren't it. So that's another approach. All right. Graham, will you talk about yours?
Yeah, is it correct?
Uh-huh.
All right, cool. So what I was saying about, so my first focus was to make sure that I got the measures based off the amount of squares, and then
Well, how did you do that though?
I counted the amount of squares of each distance where the line starts and then where the line ends.
Okay.
And then typed them next to it so I could have them for reference. And then I just, let's see here, I did 6.5 times 4 on both sides because that 6 is for the whole thing, but the 4 on the right is for just the amount that doesn't count that little walled off square at the bottom.
Okay.
Actually, I'm going to split screen right here so I can show you guys what I'm talking about while I'm doing this.
Sure.
So, dang it. It just pulled up text on accident. All right. Whoops.
Okay, you can annotate.
All right. You know what? I think I'm just going to move over to Safari. Here we go. So,
Okay.
dang it, it's so zoomed in. There we go. Some technical difficulties.
No problem.
There we go. Got it. So this 4 that I just circled counts for this amount right here, while this 6 counts for this amount. This walled off area, we're not going to worry about much. So that means what we're going to do is we're going to multiply 6.5, which is the height of the whole thing right here, times the 4, which is the amount of
So
width,
let me
you
ask
could
you.
say. Wait,
Okay.
that messed up. Wait.
Okay, Graham, your thinking is correct. You've got a couple numbers we want to change, but that's fine. Okay, let's look at what this tall part is. Okay, it's 1, 2, 3, 4, 5, 6, right?
Yeah. I
Times,
actually saw
say again?
Yeah, it's 5.5, wouldn't it be?
It's actually 6 because you go all the way to the top.
Oh, right.
All right.
I was counting the squares to either side.
Okay, so let me ask you this question. Can we put in this? Can we box this part off and say that is 4 times 4?
Yes.
Okay.
Wait.
And
Yes.
okay, and can we box this part and say it's also 4 times 4?
Yes, because they're the exact same size, so they would have the same measurements.
Okay. So I'm going to put in 16 for both of these, right?
Yes.
Okay. And where's my, oh, here it is.
Oh, right. Now I remember my thinking. Yeah, I was doing 6.5 times the 4 up here where the slant is, which probably isn't out proper.
So you're good on those two, right?
Yes.
Okay. Are we all good with this bottom box down here also being 6 total? This box is 6, right?
Yeah,
So all
because
we have
it's 2
left,
times 3.
right, 2 times 3 is 6. Okay. All we have left to do is get this triangle and this triangle.
So
Which
it's
are
3
easy.
times
Go ahead.
4? It's
So
3 times 4, because the 3 that labels the 6, the length of the 6.
Okay, so
Wait.
you're right, it's 4 across, but it's 2 high.
Yes.
So that's 8, and half of 8 is
4, but then we
4. So we
double it
have a
since
4
there's 2.
here, and we have a 4 on the other part, right?
Yes.
Now, when we add those up, we get 26 total.
Correct.
Correct? Okay. So
Wait.
let me, and I
If
appreciate.
we add what up together?
Say again?
If we add what parts together?
So if we add this 16 and this 16 and this 4 and this 4, that's
That
20
should be
and 20.
40.
40, yes. Did I say something else? 40
You said like
plus,
36 or something, and I'm like, no, that's not
no,
right.
you're right. So that's equal to 20 and 20, which is 40 plus 6, 46.
Yeah.
Correct. All right. And here's another one that shows that. All right. And here is another one that has that done as well. All right. Let me check the time. All right. That's all we have for today because the time's about up. Okay. So again, if you have any questions about any of the composite figures today, we'll pick back up tomorrow with composite figure number 3. And I'll be back on in a couple minutes with GimKit if you want to play. Thank you guys for your focus and attention, and thank you for Zoom for not crashing. All right. See you guys,
Bye, guys.
over on the GimKit.
See ya.
All right. Bye.
See you guys.
See ya.
Bye.
Bye.